Bismillahirrahmanirrahim. Assalamu alaikum dear students. This is our next video. In this video we are going to solve four problems of mathematical methods in physics. Okay? How many problems? Four problems. Four problems of mathematical methods in physics. All these four problems have been taken or chosen or selected from the same book, Advanced Engineering Mathematics by Dennis G. Zill. Okay. As usual, we first come to its statement. Okay. MMP, Mathematical Methods in Physics, problem number 22. Find the area of the triangle determined by the points P1 111, P2 121 and P3 112. Dear students, before going to its solution in a formal or regular manner, we need to go through some snapshots. In these snapshots, we will get the basic idea about this calculation regarding area of a triangle and also area of a parallelogram. Okay, so this is the snapshot. It consists of two parts, figure, because there are two figures. Okay, yes, this is the only snapshot. Now we go through this snapshot. This snapshot says areas. Two non-zero and non-parallel vectors A and B can be considered to be the sides of a parallelogram. The area of a parallelogram is A equal to base into altitude. Okay, from figure so and so we see that so and so alternatively area of A is equal to magnitude of cross product of A and B. Okay, likewise from figure so and so we see that the area of a triangle with sides A and B is area of a triangle equal to half of the magnitude of the cross product of A and B. Okay, so dear students, from here we can easily conclude that what is the almost same procedure is applicable for the determination of the area of a triangle as well as area of a parallelogram. Okay, the only difference is that in case of triangle we have to divide that area by 2. Okay, that is to say area of a parallelogram is equal to magnitude of the cross product of A and B, while area of a triangle is half of that magnitude. Okay, that is to say only half is the difference. From this figure is also the same which has been referred in our earlier statement. Okay, so we do not waste more time on this and we come to our solution in a formal manner. Okay, P1 111, P2 121, P3 112. Now vector P1 P2 is equal to, because it is P1 P2, so x coordinates of P2 will be taken and then x coordinate of P1 will be subtracted from it. Similarly, y coordinate of P2 will be taken and y coordinate of P1 will be subtracted from that. Similarly, z coordinate of P1 will be subtracted from z component of P2. Okay, when we will find the vector P2 P3, then x component of P2 will be subtracted from x component of P3. Similarly, y component of P2 will be subtracted from y component of P3, and Z component of P2 will be subtracted from Z component of P3, and along with these we will write I, J and K. Okay. So P1, P2 becomes equal to 1 minus 1 I plus 2 minus 1 J plus 1 minus 1 K, and this after simplification becomes simply equal to 1 J or simply J. Okay. Similarly, vector P2, P3 becomes equal to 1 minus 1 I plus 1 minus 2 J plus 2 minus 1 K, and after simplification it becomes equal to minus 1 J plus 1 K, or simply minus J plus K. Okay. Now we take cross product of these two vectors. Okay, we know that vector product or cross product of these two vectors is taken in this manner, that in the first row we write I, J, K, and in the second row we write first vector. Okay, and in this third row we write the components of the second vector. Okay, so we will expand it from first row. Then okay, when I will be taken, then first row and first column will be treated to be omitted or eliminated, and we will write I into minus 1 raised to the power 2, because here for I, number of row and number of column are both 1 1, so 1 plus 1 equal to 2 into this 1 will be multiplied with 1 minus this. Okay, so 1 minus 0, 1 minus 0, this is okay. Now plus J. In case of J, we will write minus 1 raised to the power 3, and it will finally give minus J, because J occurs in second column and first row. So 1 plus 2 or 2 plus 1 equal to 3. We know that even power of minus 1 is always plus 1, while odd power of minus 1 is always minus. Okay, so in J, 1 is 0 minus 0, 0 minus 0. Similarly with K, minus 1 raised to the power 4, third column and first row will be treated as eliminated or omitted. Okay, so 0 minus 0, 0 minus 0, and hence after simplification it finally becomes equal to I. And now we come towards P2, P2 P1, P2 into P2, P3 magnitude. Okay, actually dear student, we have in the above step we have taken cross product of these two vectors P1, P2 cross P2, P3. Now we are going to take magnitude of this cross product. Okay, so magnitude of this cross product will be equal to under root into square plus square plus square. Okay, value written with I will be taken as square, and value with J will be taken as square, and value along with K will be taken as square, and then whole under root. But here, because only one is present, so we do not need to use the sign under root, and hence magnitude of P1, P2 into P2, P3 becomes equal to 1. And we know that area of a triangle is half into magnitude of the cross product of those two vectors, and hence area will become equal to half. Dear students, area is always measured in square, while volume is always measured in cube power 3. Okay, so here half square unit we will write along with half square unit, because area is always square while volume is always cube. Okay, so dear students, this is our problem. This was problem number 22. Now we are coming towards problem number 23. Now we will not waste so much time. We will deal with this problem in a rapid manner. Okay, find the area of the triangle determined by the points P1 0 0 0, P2 0 1 2, P3 2 2 0. Okay, solution: P1 0 0 0, P2 0 1 2, P3 2 2 0. P1 P2 vector will be equal to this after simplification j plus 2k. Okay, 1j plus 2k. Okay, similarly vector p2 p3 is equal to this. After simplification it becomes 2i plus 1j minus 2k. Okay, when 1j we do not need to say 1j, simply j is enough. Okay, now we will take a cross product of these two vectors. Okay, we know that cross product, we do not explain this product step by step. Okay, cross product of p1 p2 and p2 p3 becomes finally equal to minus 4i plus 4j minus 2k. In the next step we will take magnitude of this cross product. Okay, it will become 4 square plus 4 square plus 2 square, that is to say 16 plus 16 plus 4. It will become 36, and under root of 36 is 6, and then that 6 will be divided by 2, because area of a triangle is half of the area of the parallelogram. Okay, so dear students, here magnitude of the cross product of p1 p2 and p2 p3 becomes equal to 6, as I have already told, explained. Okay, similarly area of a triangle is half of the area of the parallelogram, and hence a becomes equal to 3 square unit. As usual in with previous problem, area is always square while volume is always cubic. Okay, now we are coming towards problem number 24. Find the area of the triangle determined by the points p1 1 to 4, p2 1 minus 1 3, and p3 minus 1 minus 1 2. Okay, solution: p1 1 to 4, p2 1 minus 1 3, p3 minus 1 minus 1 2. Okay, now here p1 p2 vector will become finally equal to minus 3j minus k. Okay, and vector p2 p3 will finally become minus 2i minus k. Okay, we do not give more time to this step. Okay, I think we should move forward. Okay, now cross product of these two vectors will become equal to this, and finally after simplification it becomes 3i plus 2j minus 6k. Next step is to take magnitude of this vector, and hence magnitude will become square of this. Okay, 9 plus 4 plus 36. Okay, under root. Okay, so magnitude will become 9 plus 4 plus 36 under root 49 under root, and it becomes 7. And we know that area of a triangle is half of the area of the parallelogram, so we have to divide it by 2, and hence our area of triangle will become equal to 3.5 square unit. As in the previous problem, area is always square while volume is always cubic. Okay, now we are coming towards problem number 25. Okay, find the area of the triangle determined by the points p1 1023, p2 006, p3 246. Okay, yes students, now we are going to find p1 p2 and p2 p3 vectors. Okay, p1 103, p2 006, p3 245. Now vector p1 p2 finally becomes equal to minus I plus 3k. Similarly vector p2 p3 becomes finally equal to 2i plus 4j minus k. Okay, we do not give more time to this step. Now we get the cross product of these two vectors, and we know how to find cross product. Okay, so cross product is given as in this manner: ijk, and then p1 p2 vector, and then p2 p3 vector, and then simplification, and then after simplification we finally reach the conclusion that cross product of these two vectors, that is p1 p2 vector and p2 p3 vector, becomes equal to minus 12i plus 5j minus 4k. Next step is to take magnitude of this vector, and hence magnitude of this vector will become square of this plus square of this plus square of this whole under root. Okay, so square of 12 is 144, square of 5 is 25, and square of 4 is 16, and hence it will become 185 under root, and value of 185 under root becomes equal to 13.60. But we have, actually this is the area of the parallelogram, but we have to find the area of the triangle, and we know that area of triangle is equal to half of the area of the parallelogram, and hence area of triangle A becomes equal to half of the area of parallelogram, that is half of the 13.60. This becomes equal to 6.80 square unit. Okay, because area is always square while volume is always cubic. Okay, this is the end of our problems. This is the end of our video consisting of 4 problems. Till next video, Allah Hafiz.